Hello everyone. Last time we worked on correctly converting the LOD3 mesh that was retopologized with Metahuman Topology to LOD0. In this video, I would like to share the process of automatically generating 7 LODs using only this LOD0 mesh and automatically separating the head and body parts without any seams. First, let's load the Metahuman body template like we did last time. Again, please go to the meshEdit tool tab. It can automatically split or combine meshes based on a reference mesh. We will use this feature to correctly separate the character's body and face without changing the vertex IDs. Now, let's register the combined mesh that will serve as the reference, just like last time. When registering the mesh, make sure there are no duplicate names. Let's take a look at the mesh we loaded as a template. It's the same shape but loaded for each LOD, right? We will use this body LOD0 mesh to automatically separate the only body of this character. First, let's rename the target mesh. First, select the body LOD0 mesh, and then select our target mesh. Since we have already registered the combined mesh as a reference, simply click the Split Combined Mesh button here. Notice that a new mesh has appeared. As we wanted, only the body mesh has been neatly separated. The logic behind this process uses blend shape and wrap, so you can rest assured that the vertex IDs will not change. Using the same principle this time, click on the head LOD0 mesh first. Then select our target mesh and click the same button. Now, meshes for the body and head have been separately generated, right? Let's check if there's a normal seam between the two meshes. Yes, it's seamlessly smooth with no visible seam, right? The reason the seam is so smoothly handled is because these two checkboxes are enabled. This time, let's disable these two checkboxes and proceed in the same way. Select the head LOD0 mesh, then select our target mesh and click. Select the body LOD0 mesh, then select our target mesh and click. Now let's compare the difference from before. Here you can see the seam line. This logic matches the normals of our target mesh to prevent the formation of seam lines. Additionally, if needed, it unlocks the normals in areas excluding the boundary line, allowing for free deformation while ensuring the normals of the mesh are recalculated in areas outside the boundary line. Now, since we shouldn't have seam lines in our case, let's enable these two checkboxes and proceed again. The process of splitting meshes might be a bit confusing at first, so practice it several times. Once you get the hang of it, you'll be able to do it quickly. Also, this functionality can be incredibly useful in many situations. Let's check the results with the checkboxes enabled once more. Yes, there are definitely no visible seams. Rigging with this result will ensure that you won't have any normal-related issues when you bring it into your engine later on. So far, we've only worked with the LOD0 mesh, right? At the beginning of this video, I mentioned that we would generate 7 LODs for our character. Before separating the head and body, the first thing we need to do is generate the LODs from the combined mesh. Think of what we've done so far as a test of the split combined mesh function. Now, it's time for the real work. To generate multiple LODs, we will again utilize the features of meshWarp. Register the combined LOD0 mesh from the template as the driver mesh. Then, register the remaining 6 LOD meshes as driven meshes. As I mentioned last time, the driven meshes will follow the driver mesh. Also, register our character's target mesh. However, this time, instead of using the nearest vertex, we will set it based on UV. All these meshes use the same UV space, so UV mode is preferable. The closest mode might cause issues with the eyelid or mouth areas, as it may not properly distinguish the vertices from the upper and lower regions, causing them to tear. Click the Warp button. Alright, all 6 LODs have been automatically generated now. Let's proceed to delete the unused mesh groups. It's better to remove them to avoid potential name conflicts later on. Before deleting, let me delete the del group first. Deleting it will bake the mesh in its current state, as I mentioned last time. Let's clean up by removing unused materials as well. Before proceeding with the next steps, let's ensure unique names to prevent conflicts with the template meshes. I'll remove the prefix m_med_nru and rename the parent group as well. When reloading the template, it's crucial that names do not overlap. Now, please reload the Metahuman body template. From now on, as I showed you with the initial split combined mesh function, we'll separate the head and body for each LOD. Earlier, when I showed you the split combined mesh function, we manually selected and split each part one by one, right? But now, since we have 7 LODs to work with, I've included a feature here that can automatically handle this process in batch mode. These batch functions in the work list automate the command list creation for the process you just did. You can create and save this list, and then load it again to use anytime you need. All right, let's create this batch list. It's similar to how we used the split combined mesh function earlier. First, please select the split mesh in the template. Next, select your character's mesh with the combined topology. Then, select the template combined mesh for reference and click Register Source Target. We'll do the same for the head. All right, let's include LOD1 in the list this time. We can skip body LOD1. It might be a bit obscure for most, but with metahuman heads, LOD0 and LOD1 have matching edge flows with body LOD0. So you can skip body LOD1 because we already have body LOD0. Let's press the Batch Split Combined Mesh button. Great, it successfully separated the body and head all at once, just as we wanted. You can even create as many lists as you need. The head LOD one turned out perfectly. Now, let's extend this command list to include the remaining LODs, so we can separate the head and body for all LOD meshes at once. For body LOD 1, since its edge flow matches with head LODs 2 and 3, we need to select our mesh as LOD 2. For the head, we'll start with LOD 2, so let's select it and add it to the list. Head LOD 3 matches the edge flow of body LOD 1. You can think of the edge flow alignment in multiples of 2. This batch list process can be quite confusing at first. However, I've placed a JSON file in the meshWarp tool folder that you can load to get this list. Just understand that this is how the process works in principle. The remaining LODs follow the same principle. Think of the separation in multiples of 2. Head and body pairs are 0 and 1, 2 and 3, 4 and 5, 6 and 7. There is a pattern, so once you understand it, it won't be too complicated. Let's proceed slowly with the rest. Please follow along carefully. All right, now that we have created all the command lists, let's click the Batch Split Combined Mesh button. Now, let's temporarily turn off the other meshes. Let's check the final result. Set of body 0, head 1. Set of body 1, head 2, head 3. set of body 2, head 4, head 5. Set of body 3, head 6, head 7. By doing this, we have completed creating all the LODs and accurately separating the body and head. Now, let's delete the unnecessary mesh groups. We only need those meshes. If you followed along up to this point, the process might have been a bit complicated, but you've done very well. I'll also delete the unused materials. Now let's copy the head LOD0 mesh from there. Using this head LOD0 mesh, we'll create meshes related to the face, such as the eyeballs or eyelashes. Alright, now let's create additional meshes like eyeballs, eyelashes, and teeth, using the Metahuman face templates and the head LOD0 mesh as a base through meshWarp. First, let's temporarily load the original character model as a reference. Once it's loaded, let's take a look at how the original eyeball is designed. Alright, this is how it looks. The shape of the eyelashes is quite different from the existing metahuman ones. Now let's load the metahuman face templates in meshWarp. Let's load them as Ada here. The relative size is quite different from our character. First, let's register the LOD0 face mesh of this template as the driver mesh. Next, we'll register the remaining additional meshes as driven meshes. For the teeth or saliva, set the option to scaled volume. For the eyeballs, set both sides to scaled. These settings ensure that the size and proportion are maintained without distortion during the warp. Other meshes should deform to fit the character's shape, right? As Ada mesh changes to our character, the additional meshes will follow suit. Register the target mesh. And once you're ready, press warp. All right, the meshes have changed, right? Let's take a closer look. First, the eyeball is piercing through the eyeshell area. If you select the mesh and look at the channel box, you can see various parameters. I will adjust the position a bit using the offset values. After modifying the left eyeball, I will mirror it to the right mesh later. Upon checking the eyeshell mesh, it seems there's too much deformation, resulting in poor wire flow. Shall we smooth out this wire flow? Select the mesh and go to the proximity wrap settings in the attributes. Let's increase the smooth influence. Please use this carefully as it can control all meshes at once. A value around 10 seems appropriate. But now that I look at it, the eyelash mesh has become very small, right? In this case, let's select the head mesh and increase the scale percent. This parameter controls the relative size, so let's raise it significantly. You should see the eyelash getting bigger. This way you can redesign other meshes as well. Now let's adjust the offset of the eyeball again. Shall we compare it with the original? Let's also roughly match the size. In fact, using the original eyeball is also an option. However, in this tutorial, I will show you the entire process of adjusting all the meshes based on metahuman meshes. Additionally, it is convenient to convert all your character meshes to metahuman meshes when working with LODs. Through this process, I want you to understand that you can easily modify and customize your character meshes based on different meshes. The position of the pupils in the eyeballs isn't correct. Since meshWarp parameters don't support rotation, this will have to be adjusted manually. For now, let's adjust other meshes using parameters, and then come back to fine-tune this later. Now let's adjust the teeth. I'll tweak them a bit so that there's not a big size difference from the original. The saliva isn't really necessary, but I'll roughly match it as well. We just need a rough adjustment for now, since we'll be fine-tuning it later anyway. All right, now let's return to the eyeball and align the pupil position. Before manually modifying the vertices, make sure to delete del BD scaled set group to bake the mesh first. Clicking the del attribute button will also remove the parameters attached to the mesh. Now, let's proceed with the manual adjustments. Do not touch the transform of the mesh itself. Instead, select and modify all the vertices of the mesh. These meshes must be positioned at the center of the grid. Even after adjusting the pupil position, it still pierces through the eye shell, right? Grab the central vertex and slightly move it inward. And let's adjust it a bit further back. The eyeball doesn't need to be in exactly the same position as the original. It's much better for the eyeball to be slightly further back to avoid any interference, rather than having it intersect other meshes when it rotates. An important point here is to make sure to perform a rotation test. Check if there are any intersections when rotating up, down, left, and right. Good. Now there are no more intersections. As long as there's no significant difference from the original eyeball, it's fine. Now I'm going to mirror the shape of the left eyeball onto the right eyeball. First, please duplicate the left eyeball. Change the scalex value to -1, and then freeze transform. This will reset the scalex value to 1 and preserve the shape. However, this method may reverse the original vertex IDs. To fix this issue, we'll use Maya's transfer vertex order feature. First, select 3 vertices from the original right eyeball. Next, select the same 3 vertices on the eyeball we just created. This will preserve the vertex IDs, allowing us to use it as the metahuman right eyeball. This process is crucial, so please do not skip it. Great. Now that we have created the new right eyeball, let's delete the original right eyeball and rename the new one with the same name. All right, it seems we're almost done here. The saliva mesh here is bothering me a bit. Now, let's make some adjustments to it as well. As mentioned earlier, you should modify it using vertices. Never use transform to modify it. The object's transform pivot should not move away from the grid center. Now that everything is created, let's take a look at the overall result. All right, let's tidy up the meshes now. Please separate out the mesh group we created earlier. We'll now delete the original character that was loaded as a reference. The remaining meshes from Ada are no longer needed, so we'll delete those. The target mesh is already included in the group from earlier in the same form, so it's no longer necessary. I'll rename this group to ensure there are no duplicates. It's a good practice to always prefix your final character meshes with a unique name. When using templates, duplicate names can often occur. Great job. It looks very tidy. With just the LOD0 combined mesh and the meshWarp tool, you've created all LODs, split body and head meshes, and all additional meshes for this character. If you followed along up to this point, you've done an amazing job. Developing adaptability through this process will enable you to apply these skills in various other situations. Now that you've completed all steps to modify the character mesh before rigging, we're done. Starting from the next tutorial, we'll proceed with Metahuman rigging. Modifying this mesh was the most challenging part. You've done really well. See you in the next tutorial on rigging process.